A superhabitable planet is a world where life is more likely than our home Earth. Because Earth is the only planet known to be inhabited by humans, and life on it depends on liquid water, efforts to identify exoplanets that might host life have focused on Earth-like planets. But some scientists believe that other types of planets may also have life-supporting conditions as good as Earth, or even better than Earth. In fact, some scientists believe that focusing only on Earth-like planets may be too geocentric and blind us to the complexities of outer space. We've been so focused on finding a mirror image of Earth that we've neglected a planet that's more hospitable to life. To search for potentially superhabitable exoplanets, some scientists investigated the Kepler Object of Interest Exoplanet Archive, focusing on 4,500 planetary systems that likely possessed rocky planets within their stars' habitable zones, where liquid water can persist. In addition to studying yellow dwarf planetary systems like our Sun, scientists have also studied orange dwarfs, which are cooler, dimmer and less massive than our Sun. In fact, our Sun isn't the best star for a planet to host a lot of life. There are 50% more orange dwarfs than yellow dwarfs in the Milky Way. The Sun is estimated to be less than 10 billion years old, while orange dwarfs live between 20 and 70 billion years. Since it took about 3.5 billion years for complex life to emerge on Earth, the longer lifespan of orange dwarfs may give planets in their habitable zone more time to develop life and accumulate biodiversity. Earth is about 4.5 billion years old, so scientists speculate that the sweet spot for life is a planet between 5 billion and 8 billion years old. Also, the size and mass of a planet can affect how well it can support life. A rocky planet larger than Earth would have a more habitable surface area and likely have a thicker, more stable atmosphere. A planet with about 1.5 times Earth's mass would likely retain its interior heat longer, which in turn would help keep its core molten and its protective magnetic field active for a greater time span in which life might have the chance to arise and evolve. Planets that are slightly 8 degrees Fahrenheit, 5 degrees Celsius, warmer than Earth are likely to be superhabitable, because they may have larger tropical regions that can support more biodiversity on Earth. However, warmer planets may also require more water, as higher heat could expand deserts. Planets with the same land area as Earth, but broken up into smaller continents, might be more habitable. When a continent became particularly large, as in the past, Gondwana, about 500 million years ago, its center moved away from the ocean, often turning the continent's interior into a vast, inhospitable desert. In addition, Earth's shallow waters hold more biodiversity than deep oceans, so scientists speculate that shallower planets may support more life. Finally, some scientists identified 24 potentially superhabitable planets. None of these worlds met all the criteria they drew up for superhabitable planets, but one did meet at least two, that is KOI 5715.01. KOI 5725.01 is a roughly 5.5 billion-year-old planet with a diameter 1.8 to 2.4 times that of Earth, orbiting an orange dwarf star 2,965 light-years away. Its average surface temperature may be 4.3 degrees Fahrenheit, 2.4 degrees Celsius, lower than Earth's, but if it has more greenhouse gases than Earth to trap heat, it could be superhabitable. All 24 of these potentially superhabitable planets are more than 100 light-years from Earth. This prevents NASA's TESS spacecraft from capturing high-quality images to learn more about them. Still, future spacecraft, such as the newly launched James Webb Space Telescope, NASA's LUVOIR Space Observatory mission concept and the European Space Agency's Plato Space Telescope, could shed light on these worlds. The planets we're looking for are indeed superhabitable, but that doesn't mean they necessarily harbor life. A planet can be habitable or superhabitable, but uninhabited.